now we're going to look at factoring quadratics. So if we're going to factor in quadratics, you should probably know what quadratics are. So quadratics are an expression where the highest exponent is x squared or y squared or p squared or whatever squared. They come from, well, the idea behind a square. If you have a square, draw it out. And you take the area of a square. Area of a square is just length times width. Square has the same, all four sides are the same. So area would just be x squared. Square is also known as a quadrangle, or is a type of quadrangle. So that's where they get the word quadratics. Not that important, just interesting. Hey, so we've seen quadratics. When we were foiling, we saw quadratics quite a lot. So if I FOIL, I multiply the first times the first, so x times x is x squared. Outer, x times 7 is plus 7x. Inner, 4 times x is plus 4x. And last, 4 times 7 is plus 28. So when I FOIL, I got x squared plus 11x plus 28. So when we factor quadratics, this would be a quadratic. When we factor quadratics, there's a good chance that they're going to factor back into those two binomials, those two things that could be FOILed. So we need to see if we notice any patterns. Well, we know we got this x squared here from my first two terms, my x and my x being multiplied together. So when I factor a quadratic, let's say a quadratic like x squared plus 6x plus 8, I can look at my first term, my x squared, I should get from multiplying my first terms together. So x times x. Okay, we got that last term, the constant, from multiplying together the 4 and the 7. So we said, okay, we multiply stuff together to give me a 28. We got that middle number by adding the 4 and the 7. 4 and the 7 got multiplied by the x, and then we added them. So to find our last numbers, or our last terms in our quadratics, we need to find the numbers that multiply to give you the last number. So multiply to give you the 28 in our example, and add to give you the middle number. So add to give you the 11. So the one we want to try down here, x squared plus 6x plus 8, that means I'm looking for numbers that multiply to give me 8 and add to give me 6. There's not many choices. So with 8, I have the two choices, 8 and 1, 4 and 2. So all I have to do is add them and see if any of them add up to give me 6. 4 and 2 will work. So it should factor to x plus 4, x plus 2. Of course, I want to check this, make sure I'm right. So I'm going to check it by FOILing it out. So if I FOIL it out, first, x times x, give me x squared. Outer, plus 2x. Inner, plus 4x. Last, plus 8. Yeah, so it does FOIL out to give me what I started with. So my answer should be x plus 4, x plus 2. So it doesn't seem as much like math as like playing with numbers, and that's kind of what factoring quadratics is. It's kind of trial and error. You're just playing with numbers. So let's look at my next one. Say I have x squared plus 17x plus 30. Again, my first term is x squared. I know my first have to multiply to that. So I'm going to get x and x. They multiply to give me x squared. Now I'm going to look for numbers that multiply to give me 30 and add to give me 17. So 30, I got quite a few options. I'm going to write down my options. I have 30 and 1, 15 and 2, 10 and 3, 4 doesn't go into it, but 6 and 5 go into it. And I need to find ones that add up to give me 17. 15 and 2 will work. So I should get x plus 15, x plus 2. To check it, I just FOIL. Okay, let's try the next one. Say I have x squared minus 9x minus 10. So I'm going to factor this. It's a quadratic, so it's probably going to factor to these two binomials if it is factorable. So first term is x squared. I'm going to get x and x. I'm looking for numbers that multiply to give me a negative 10. Don't forget signs are important. Every other one's been a plus, but we still have to pay attention to the signs. And add to a negative 9. So multiply to negative 10, again I'm going to write this up here. I have 10 and negative 1. I have negative 10 and positive 1. Because multiply and negative have to have opposite signs. I have 5 and negative 2. Negative 5 and 2. If I add them, the ones that are going to add to a negative 9 is going to be my negative 10 positive 1. So minus 10 plus 1. Again, FOIL it out to check. Let's try another one. X squared plus 8x minus 20. Again, it's going to factor to two binomials if it's factorable. First term is x squared, so I'm going to have x and x. I need to find things that multiply to negative 20 and add the positive 8. So, I can write out all my options for 20. 20 and 1. 10 and 2. I'll play with the signs in a second. 3 doesn't go into 20. 4 does 5 times. So I only got 3 options. I know I'm multiplying to a negative, so it has to be opposite signs. This time I'm adding to a positive. If I'm having opposite signs where I add to a positive, that means my smaller number has to be the negative. If I have opposite signs where I'm adding to a negative, then my smaller number had to be a positive. So whatever I'm adding to, that's what my bigger number is going to end up being. So I really only have to check 3 options. 20 and negative 1? No. 10 and negative 2? Yeah, that's going to work. If that doesn't make sense, you can check all 6 options. You'll get the right answer. Okay, let's try next one. So x squared plus 4x plus 1. Again, I'm going to write out 2 binomials. X and x at the beginning, because that multiplies, give me x squared. And I'm looking for things, I'm going to start doing shorthands that multiply to positive 1 and add to positive 4. Things that multiply to positive 1 are 1 and, 1. That's it. They do not add to 4. So, I can't find 2 numbers that work. This is where not factorable, shorthand, NF, or prime comes in. This is not factorable. It is prime. We'll learn how to solve this in, November. Therefore, let's go to the next one. Say we got x squared minus 6x plus 9. Again, trying to factor it. Multiplying x squared, so that'll be x and x. Need to multiply the positive 9, add to negative 6. I'm going to write out everything that multiplies to 9. I got 9 and 1, 3 and 3. Neither of them add to negative 6 though. Well, if I'm multiplying to a positive, that just means they have to be the same sign. So they don't have to both be positive, they could both be negative. So I can try this. Negative 9, negative 1, no, but negative 3 and negative 3, yes. So x minus 3, x minus 3. This isn't the simplest way I could write this. Because they're the exact same binomial, I can actually simplify this by writing x minus 3 whole thing squared. And I do want to do that. It is not considered correct if it is not written as that binomial squared. Let's try the last 2. So x squared minus 13x plus 30. I'm going to write out my 2 parentheses. First terms are going to be x and x. Looking for things that multiply to positive 30. Add to negative 13. I'm going to write out my options for 30. If you start to just see it in your head, you can skip this step. So I got 30 and 1, 15 and 2, 10 and 3, 4 still doesn't go into it, 6 and 5. Okay, I am multiplying to a positive, so that means they have to be the same signs. But I'm adding to a negative, so those same signs should be negative. Now I just have to add. Do any of them add up to give me negative 13? And yeah, negative 10, negative 3. Okay, gonna try the last one. So x squared plus 5x minus 24. First term, x and x. Looking for things that multiply to negative 24. Add to positive 5. Again, I'm just going to write out my options. So 24 and 1. 2 goes into it 12 times. 3 goes into it 8 times. 4 goes into it 6 times. 5 does not, so I'm done. Multiplying to a negative, so they have to be opposite signs. And since I'm adding to a positive, I know my bigger number has to be positive, so I'm going to put the negative with my smaller number. If I put the negative with my bigger number, they would add to a negative. Okay, so does any of them work? Yeah. Positive 8 and negative 3 should work. How would I check all of these? I would go ahead and FOIL it, especially on a test, you should check.